Hello, everybody. We're going to start Unit 6 today, which is linear functions. Just a few things to mention about this unit. You'll notice that the packet is a little bit thicker than it typically is. We're going to spend a lot of time with linear functions. These skills will all be used next year in geometry or applied geometry. So it's really important that you understand how linear functions work. Every single graph this unit is going to be in the shape of a straight line. All right, that's what linear means. So let's take a look real quick at the word linear. It has the word line right in it. Okay, all of these will be straight lines. All right, so today we're going to look at section 1, which is just a quick intro. So a linear function, like I said, is a function whose graph is a line. Again, it has the word line right in it, since it has a constant rate of change. Now, what that means is constant means it's going to be the same rate of change. So it's going to change the same amount each time. So the same amount of change as you move across the graph. So you're going to be adding or subtracting the same number all throughout. So today I just want to focus on figuring out if something is a function by looking at a table, a graph, and an equation. So let's start with a table. We want to decide whether these are linear or nonlinear. So it's either a line or it's not. And you might say, well, I can't tell, I can't look at the picture. But what you want to look at is how much your x and y's are changing. So in this first one, to get from 4 to 5, we add 1. 5 to 6, we add 1. Add 1, add 1. So that's changing the same. All right, but the y column is typically where it's at. So 8 to 11, we have to add 3. 11 to 14, we add 3. 14 to 17, we add 3. 17 to 21, oh, be careful. That would be an adding 4. Since you're not adding the same amount each time, this is non-linear. Because of this guy right here. It's not equal. All right, so in the next one, you can see that, again, all of these were just adding 1. All right, over here, we're going from 5 to 3 is minus 2, minus 2, minus 2, minus 2. They're all the same. They're decreasing by the same amount each time, so it's linear. And a lot of times it'll say explain. By showing me this work, that's your explanation. All right, in the next one, check the x's going up by 1, by 1, by 1, by 1. Okay, everything's good there. Over here, to get from -1 to 0, add 1. 0 to 3, add 3. I can tell already it's not linear. Add 5. Add 7. Got a nice little pattern going on there. But again, you have to add or subtract the same amount, so it's non-linear. Okay, because those are not equal. And by looking at the first one, you can see, oh, it looks like it's linear, but check them all just to be safe. Sometimes your tables will be written horizontally. Do the same thing. This time your x's, you're going up by 3. By 3, by 3. Okay, that's good. Over here, subtracting 8. To get from 32 to 24, subtract 8. If you're not sure, you've got a graphing calculator at your hand. Hold on. You can use... Oh my goodness. You can use this anytime. So if you're not sure, again, to get out of the table, just hit second mode. It'll quit you out. So if you're not sure what the difference is, 24 minus 16, it'll tell you 8. So I went down 8. Since they're all equal, this is linear. It would form a straight line. All right, next one, going up by 2, up by 2, up by 2. Okay, good to go there. 2 to 11, we'd have to add 9. 11 to 33, whew, add 22. Add 55, yeah, no, not linear. And that's it for tables. All right, now Graphs are even easier. Does the graph represent a linear or nonlinear function? Do you see a line? Is this a straight line? No, so it's nonlinear. This one here might be kind of hard to see. It's along the bottom. That is linear. And this one, it looks like two straight portions, but again, the whole thing needs to be one big straight line, so that's nonlinear. Super easy with graphs. All right, equations might be a little bit trickier, but guess what? You are going to use your calculator. There we go. Forgot that C. Anytime you are putting an equation in, you're going to just hit y equals, type in the equation, and then we're just going to look at the graph. I mean, you could see it in the table too, but you'd have to count. Why not just look at the picture? So I'm going to grab my graphing calculator. I'm going to go to y equals and type in my first one. Y equals, so that's the left side. So I'm just going to type 4.7. Take a look at the graph. All right, it's just a straight horizontal line. So that is linear. So I'm going to just sketch that. This is how we explain. So there's that line. That's linear. So we're good. We're looking for nonlinear. All right, what about this next one? Y equals pi x. What? Y equals pi. There's actually a button right here, right below clear. You'll see the pi is blue. So to get to it, we're going to do our shift. So second pi and then x. Take a look at the graph. That's a straight line. The table might not be very pretty. Ooh. But we don't care. We're going to look at the graph. So again, sketch that for me. Here's your x and y axis. It was just a straight line. So that one's linear. All right, next one, 4 over x. All right. Remember how to do a fraction? So we'll clear it out. To do the fraction, it's alpha y equals. And hit enter. So alpha y equals. We'll bring up your fraction. If needed, take little notes like this in your packet if you can't remember that, because you can use this anytime on your quizzes. I'm just going to get my x and y axes ready. So y equals 4 over x, so hit 4, down, x. Well, that's definitely not linear. Again, just sketch it. So that's non-linear. That's going to be your answer. But let's just take a look at this last one, because apparently that's going to be linear, but let's just be sure, because sometimes you might type it in wrong. 4 parentheses x minus 1. Close your parentheses, take a look at the graph. Good to go, straight line. So this is the only one that's nonlinear. All right, so does the equation represent a linear or nonlinear function? Explain. To do this, just draw your graph. That's all you got to do. So I'm going to get my axes ready to go. Change up my pen here. Use a different color. All right, so y equals x plus 5. Clear. X plus 5. Take a look at that graph. That's linear. There's my explanation. All right, next one. Well, this one was nonlinear, so maybe because it's a fraction, it's going to be nonlinear. Let's take a look. Clear. Alpha y equals 4x over 3. Okay, 4x, down arrow, 3. Oh, this time the fraction is linear. So don't just assume. All right, last one, y minus x squared. Are we going to have 1 minus x squared. Are we going to have 3 linears? Let's see, 1 minus x squared. Nope, that's a parabola. Okay, that upside down U. And the reason is this squared. All right, so let's just sketch it. This makes it so it's nonlinear. That's actually a quadratic function, which we're going to talk about in the next, in a couple units from now. Okay, so what I'd like for you to do is the practice on page 4, determine if each is linear or nonlinear, and to explain, make sure that you show what it's increasing and decreasing by. Describe the difference between linear and nonlinear. Again, a couple tables, and then tell me if these graphs are linear or nonlinear. Okay, so that should be quick and easy. If you have any questions, stop by Math Lab or shoot me an email. I'd be happy to help. Have a great day.